right, getting the stream going. Sound looks good. Let's tell everyone about it on Twitter. Thanks for coming. If you are here, I am going to record this and post it on YouTube. So I'm just going to talk to myself. And also, if you're joining and you're trying to figure out what this is about, this is just sort of going to be the opening explanation for what's going on. All right, so what are we doing today? So I have this very annoying pull request that I need to review. And it's very annoying because I don't actually know how the subsystem in question works. Because I have reviewed bits and pieces of it in the past, but I've completely forgotten how memory pools and the Cuda caching allocator and Cuda graphs are supposed to work. So we're going to sort of figure this out together and maybe learn some things about these subsystems out of PyTorch. So before we get started, let's just do some high-level context here. So what is going on with this set of PRs? Well, there is some background which is useful to know about. So let's start off with the first set of background. And let me just go ahead and I don't want to put it in Claude yet. We're going to use Claude today to sort of get our thoughts in order. But let's just write a few notes. Okay, so the first thing that's important to know here is what's the Cuda caching allocator? So the Cuda caching allocator is a allocator that we use whenever you ask for Cuda memory when you're doing PyTorch programs. And instead of just directly calling Cuda malloc, we maintain a pool of memory that we've already gotten from the Cuda runtime. And we basically use this to avoid having to actually ask the Cuda runtime for memory. Because in old versions of Cuda, this was very slow, and that would have been really bad for our eager mode performance. So if we cache it, then we can do our own algorithm for deciding when we need to ask for more memory from Cuda, or we can just directly return some pointers into some blocks that we're managing, make it very fast, very important for the speed of PyTorch. One of my favorite old stories about PyTorch is that we used to have these weird used to have these weird signatures way back in the TH days. We're talking LuaTorch days, where people would allocate these buffers and then pass them to the backwards pass for like things like convolution. And I always wondered, why do you allocate these buffers? In fact, these buffers have nothing interesting in them. They're like all zeros. And the answer was, well, we didn't have a Cuda caching allocator, so reallocating this buffer would have been expensive, so we just kept it around to make things go fast. Okay, whatever, fine. Okay, so why does the Cuda caching allocator matter? Well, the Cuda caching allocator matters because it has a funny interaction with this other subsystem in PyTorch, Cuda graphs. What is Cuda graphs? So Cuda graphs is a way of making your programs run faster. And the way it works is that the Cuda runtime knows about all the Cuda kernels you're executing when you run your program. And the idea behind Cuda graphs is let's just go ahead and record exactly which kernels got executed with all their arguments sort of just burned in. And then we'll just replay them, boom, 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 without running any of the CPU host code that was responsible for dispatching them in the first place. So it's pretty hard to write low overhead software, and it's especially hard to write low overhead software if you're writing stuff in Python. So Cuda graphs lets you just eliminate all of that. The cost of it is that it's pretty inflexible. Like exactly what it is that the Cuda kernel you ran was is exactly how Cuda graphs is going to replay it. And in particular, for example, one of the important things you need to specify when you launch a kernel is where the memory addresses of all the tensors you're going to operate on. And so those memory addresses all get put into the same place. So if you want to run the Cuda graph again later, you have to make sure all of your inputs are at the same memory locations that they were the first time around. And also, if you did any intermediate allocations, those also all have to be in the same place as well. So way back in the day, we added Cuda Graph API to PyTorch Eager, and it's basically like you got to keep all the pieces. Whatever it is you do here is what you get. Okay, so let's just our next thing. So I guess this is about the point in time when the mempool abstraction came into being. Now this is where my memory is getting a little hazy. So actually, let's just look for mempool in the context. Let's see, mempool. Let's see. This is too early. Maybe we did it in Cuda graphs. Expandable segments. Better support for streams. Oh, we've done a lot of stuff in this file. Checkpointing the private state. I think I want to search for pool maybe. Better rounding. So now we're in 2021. Yeah, M. Carilli is the guy who added us to. Okay, so I think mempools. Yeah, okay, mempools came into existence in 2021, and they coincided with when we added the yes, they coincided with when we added Cuda graph support to PyTorch. And so why did we have to do this? Maybe the pull request says. Hey, I was involved in this. Ha! Oh, I've been involved in too many things. I don't even remember. What was the story here? Oh, we even have a high-level strategy document. How cool. I probably have a podcast about this too that I've forgotten. Oh. Where's the high-level strategy? He was like hypothetically linking somewhere here. Okay, but this has jogged my memory enough that I kind of understand how this works. So so we said that when you record Cuda graphs, we require the memory pointers to be exactly the same the next time around. So if you actually want to like do Cuda graphs by hand, you need some way of saying, hey, this memory that I used for my Cuda graph, I need you to keep it around. I need you to like not try reallocating it for other things. Let's see. Yeah. Exactly. Comment on the stream. This is the point where you look at the code and ask, who wrote this crap? Well, oh no, it's me. Well, I didn't write this, but I did review it. So yeah, I'm kind of all responsible for it in the end. So okay, so where are we? So Cuda graph memory pools. So we need a way to say, hey, don't reuse this memory for other stuff. Like keep it for me and go ahead and let me reuse it the next time around. And not only that, but if I'm doing intermediate allocations in the middle of the region I'm Cuda graphing, those allocations also have to get allocated consistently. They like need to be in the same spots because remember I burned in the addresses for all the Cuda graph calls. So this required some work. Like the basic Cuda graph caching allocator isn't going to give you this level of control. All it's going to do is like say, hey, whatever, you're just going to get all of the, allocations into one giant pool, and I'm just going to unpredictably, reuse stuff for later. So if I allocate something from the regular pool and then I free it and then later I ask for that address again, it might not be available because maybe someone is put a tensor there to do something else in this case. So okay, so fine. So what we're going to do, right, is the very obvious idea, which is, okay, we're going to have a private pool. In the private pool, we're not going to let people use it, right? You can only use stuff from the private pool when you're doing Cuda graph allocation. And so when I turn on Cuda graphs, I switch over to using this private pool. I do allocations. I can also free stuff, but when I free stuff, I free it back to the private pool, and I can use it again for other things. So like if I'm repeatedly allocating, deallocating something inside of my Cuda graph region, I won't keep using more and more space, which is what would happen if I just use Cuda malloc. I'm just going to reuse it, right? So I still get to do some sort of Cuda graph memory allocation in this case. And then that pool just gets bundled up with the Cuda graph, and I just have to, that memory is, can't touch this. Just make sure it is there and available and not being used for anything else for the next time you run the Cuda graph. So okay, cool. All right, so that's about mempools, and then we could talk about Cuda graph trees. But I don't think we need to talk about Cuda graph trees yet. So let's just go ahead and leave this there. So, but the important thing is that mempools were originally added because solely for the Cuda graph use case. So we didn't really, originally plan for them to be used for anything else. So that leads us to this latest pull request from Syed, which is that in his PR, he's basically taking the mempool API and generalizing it so that it can be used in other situations. Actually, I don't even remember why they wanted to use it in other situations. Oh, what's this? Oh, here we go. Okay, cool. Oh, there's even a design. Oh, how nice. I must have read this as well, and I've forgotten it as well. Okay, cool. Design doc. Okay, so what does he say here? Okay, so he's like, hey, we need to mix and match CUDA allocators, and some reasons for this is NVLS reductions require buffers to have specific alignment, and then you have to register them. Okay, so you've got some special memory for this sort of thing. And extended GPU all gathers also need to have a specific alignment. And so you want a way to mark a region of PyTorch code to use a different allocator. So there's basically no way to do this. There's no way to say, hey, do allocations in another place. It is... I wonder if we talked about this, but I do have a question, which is like, if you only need it for these cases, do you need the intermediate allocations to go into the special memory? Maybe you don't. Maybe like an out equals API is enough. Well, we'll keep reading this issue and see if there's... Okay. Is an out style API enough? Okay, so what do they say? Okay, so we're going to expose private pools to user land and allow... the general concept, I guess, is fine. Like, you have a way to go into a private pool, and then when you do a bunch of stuff, you can specify how blocks in the pool should be allocated and deallocated. And sure. Okay, so then he's like, okay, hey, we already can create private pools in PyTorch because this is the thing that we added for Cuda graphs. Is that true? Was this originally added for Cuda graphs? I'm very interested. Can we see the bottom of this? Oh, wrong terminal. Hang on. Let me do a different terminal. Also, that search is apparently very slow. CCirc maybe? Okay. So, yeah. So Cuda graph trees kind of gets involved here because I'm pretty sure the reason Elias did this pull request was because he was working on Cuda graph trees. Yeah. But I'm also thinking that he didn't actually add any new APIs. They're just all pre-existing stuff. Yeah, so let's go ahead and ask when this guy first showed up. Oh, wrong terminal. Oh, I guess I have to, let me just get rid of this terminal so I don't keep using it when I shouldn't. So this one is Oh. So Zach added this in 2023. So this is kind of Cuda graph trees era. Generalize according to a pool. And why do you do this? Previously, the allocator would query whether a stream was recording a graph and look up this pool associated with the graph. This changes an allocator directly associated. Okay. I mean, this is like fine, I guess. I don't know what he was working on during this period of time. But yeah, the basic idea is instead of, doing the pooly stuff directly when you do stream captures, instead separate it into two pieces. We could probably find out what he was working on. There was also a bug apparently in this. Maybe he was unblocking Elias at the time. Okay, let's see. So, git log. How do I want to do this? What was he working on? Flight recorder. Okay, he was doing like flight recorder stuff. And then after this one, serve multi-stream graph captures from the collect pool. Is that why he did it? Oh, this is confusing. Why did I do that? I didn't want to do that. Yeah, it got reverted. That's so funny. It's funny how these things happen. Okay, I don't know. Like, whatever. Doesn't seem that important. Okay. Fine. Okay. So at some point we factored out the private pool from the Cuda graph stuff. And so we now have this API. And I'd like to encapsulate torch.cuda.graphpool handle into a class. Okay, sure. With a alloc function and a delete function. Seems reasonable. And there's a mutex for protecting them. And then there's a little bit of generalization, so we're not doing Cuda graph mempool. And then we pass this info to the Cuda caching allocator. And then yeah, that's fine. And another container captures on your way to yeah, that's fine. And do the private pool. Yeah, sure. And then there's a Connex manager and allocation will mallow. Share allocations. Divert allocation in the stream. Follow allocator, pools. Custom allocators per pool. Lift up the... Oh yeah, so I guess Zach suggested we changed some of the extraction. And then Yokai is like, we got a lot of different allocators. And okay, fine. I don't know. We'll feed this to Claude when we want to start asking questions about the pull request in question. Okay. So, so the broader context is that Syed wants to use the pools for arbitrary stuff. In particular, he wants to be able to associate a custom allocator and deallocator to a pool that says how you get the memory. That's different from the normal way you do it. And then we need to review this PR, which is let's add a release API for mempool such that the memory can be restored to the system. This PR, okay, so I read this. I've read this PR prior to doing the stream, and I don't really understand it. So it says this PR adds a convenience function get pool use count and uses it in a release API for mempool. The use count variable in the Cuda caching allocator is essentially a ref count of how many context managers are using the pool. Hence, when marking a pool to be freed, we need to know how many times to call release pool such that use count can be decremented. When use count becomes 0, the pool is marked freeable in Cuda caching allocator, and torch.cuda empty cache can finally start releasing block solid in it. Yeah, this is just so strange to me. So the things that are strange to me, which we're going to try to figure out during this stream, is that one, why do we need to know how many times to call release pool so that the use count can be decremented? This is such a strange thing, right? Normally when you have a reference count, you increment it when you have a new reference, and you decrement it when you're done with a reference, and then when it goes to 0, you're all done. So why do I need to, well, maybe Syed is just saying this in an oblique way. Maybe he's just saying it's a ref count, and this text is just needlessly confusing. And the second thing is Syed says that the ref count is tracking how many context managers are using the pool. And he says when no more context managers are using the pool is freeable by Cuda caching allocator. But that doesn't seem quite right either. If I have a tensor whose memory lives in the pool, then I can't free the pool until that tensor is done too. So what does that mean? Also, if I have a mempool like object, I'd assume that having that mempool object around would keep the pool alive as well. So I actually already asked some of these questions in the pull request. So let's read the conversation. So I said, I'm not sure I understand this API. You deallocate this pool just by calling release on it. Are you introducing the possibility of use after free? When would I want to use this? Wouldn't it be better to make sure my tensors are all actually deallocated? And Syed says, this is more to do with how the life cycle of a pool is currently designed in the Cuda caching allocator. Consider this context manager. And Syed quotes the context manager. Use Cuda memory pool manager. This is a context manager to use Cuda graph pool for new allocations. If you use this manager, all Cuda graph tensors in use should be reflected in the allocator or they will be overridden. By the way, I think this sentence is like sort of irrelevant for what we're talking about. It's just about Cuda graphy stuff. Existing graph should have already been used in capture, and the mempool must already exist because this manager will not preserve a reference to the pool, which keeps it alive. I think this is just saying we're going to use it, but the pool has to be live independently of this stuff. Okay, so every time the user is done using the pool, release pool is called, which decrements the use count. Why? What does this mean? Huh? Yeah, this is so strange. What? Right, so why does this release pool? Okay, so this is going to be a question we're going to ask Claude later, I think. So that's one of my, okay, yeah, let's ask this. Questions. Why does use Cuda memory pool manager call release pool when it's done? Every time a user is done using the pool, release will call. Yeah, fine. That's what the code says. And then we have this code. So let's just take a look. Line 2096. This is the call and release pool. So so what does release pool do? Let's see. So it says we have destroyed the instantiated CUDA graph exec t. We can't blindly delete and CUDA free the mempool it's captured used because other graphs might still share the same pool, and the user might still hold references to output tensors allocated during the capture. So this is the thing that prevents you from use after freeing the tensor. Although I'm a little confused. So the CUDA graph exec t, that must be the CUDA graph. Why do we free the CUDA graph here? Yeah, why? Why? Let's check this code context maybe. Why? So the easiest way to figure this out is to just look at the call sites. Okay, so this call site is in run, and what this says is, what does this function do? I don't even know what this function does. So it's probably Cuda warm-up node, a simplified wrapper around a Cuda model that wraps outputs and storage routes and exposes APIs to get live storages in the current chain of warm-up. What a graph node or Cuda warm-up node? I mean, I guess this looks like something that does a warm-up run. So we don't care. Oh, I'm just gonna like blindly assume, although I haven't like actually understood the code enough to know if this is true, that this is just doing warm up. Okay, because I do know that when I do CUDA graph trees recording, I need to do some sort of warm up thingy to like basically make sure everything is ready before I actually record. So let's say that's the warm. Okay, so what is this? Allocate and copy recording inputs. Allocate inputs for non-static, non-CUDA graph managed managed tensors in the memory pool and copy over the tensor values. Is this working copy clean? Let's make this working copy clean. I'm going to start making some edits. Non-CUDA graph managed tensors in the memory pool and copy over the tensor values. So fine. So I this is saying that when I have inputs to a CUDA graph region, I need to copy them into CUDA graph memory. So I'm going to set up a CUDA graph pool, and then I'm going to go ahead and allocate a bunch of inputs. Static input does an allocation, and copy things into them. So why is it okay to release the pool here? So what I'm doing right now is I'm looking for things that look like memory management for CUDA graphs pool, like increasing its ref count or something like that. But I don't see it. I don't see any of that. All right, so one of the things that I thought I was going to do walking into this was I was thinking, you know, let's ask Claude for some help. So let's go ahead and add some context. this one. Okay, so I'm gonna give it. I can't give it all. I don't think I want to give it the entire PyTorch code base, but I do want to give it the important files. So the caching allocator is important, and I want to give it the Cuda graph trees implementation. Okay, let's see. Anything else? Maybe that's good enough for now. Okay. 42% knowledge size used. Okay, what do I want to ask now? Okay. So, got this file, we got this file. Okay, good. Okay. All right, let's ask Claude. Okay, I am trying to understand the life cycle of the Cuda graph memory pool, e.g. as seen as interacted with in formatting. In particular, the implementation of use Cuda memory pool manager seems to suggest that pool is released at the end of the context manager, but in the call sites of this function, it doesn't seem that the pool should be released, especially when we are allocating inputs for the Cuda graph region. What is going on? All right, what does Claude say? It's thinking, because I fed it a lot of context. You're right to notice. Yes, thank you. However, it doesn't manually the pool is being destroyed. This pool is part of the allocators. It decrements the reference count to the pool. The reference count is 0. Yeah, sure, fine. In the context of Cuda graphs, the Cuda pool is typically kept alive for the duration of the graph's life cycle. It's more about managing the pool's usage state rather than fully releasing it. Huh? What? When allocating inputs for Cuda graph is not fully, the graph still needs the allocations. Yes, sure. The Cuda graph tree manager class maintains a reference to the graph pool through self-thread pool. Yes, sure. So single at the end of a specific usage period rather than fully released and still available. I mean, what Claude said is like, since our prior is that the code isn't completely broken, this is not like an unreasonable thing to say, but it doesn't. Yeah. So here's what I say. So, I understand that Cuda release pool isn't going to immediately release the Cuda graph pool. But because there is a ref count, did we say ref count? Because there is a ref count involved with the pool, I was expecting there to be a corresponding increment for the ref count somewhere. Where is it? The concurrent increment of the ref count happens in, that actually would make a lot of sense. So Syed didn't quote that here, but we can check this pretty easily. C10 Cuda graph, caching allocator. Begin allocate current what function is this? Okay, so it is begin allocate to pool, and there's a predicate that says only if it's in the stream. Begin allocate to pool, and this says mempool ID references an existing pool, so increment it. Okay, mystery solved. Mystery solved. Mystery solved. It's because increments the ref count. Man, this is just such a crappy API. Maybe that's what he says later. Is this what he says later? Okay, let's read the rest of this now. Was using whatever, blah blah blah. Uses the pool, releases we don't call it just kind of fail the session. What? Huh? Okay, I think Syed did not understand. So actually, I think he is working around the problem. So let's just take a look at this. So he added a binding for get pool use count. Yeah. And then he's just calling it. And I think concretely, what is this based on? I think concretely the situation. So okay, so we're looking for places that have increased the use count. Begin allocate to pool. So is he using this directly? He had an earlier PR in the stack. Or is it a new PR in the stack? Let's check this one. Cuda mempool. Okay, so Torch, Cuda, use. Where is this coming from? Ah. It's in memory. Memory. Yeah. All right. Mischief managed. Okay, so the problem is there's a bug. Use mempool is not decrementing the ref count when it goes here, even though it's being incremented by begin allocated pool. And therefore, Syed is like, why is the ref count so high? And then he's like, okay, well, what I'm going to do to fix this is I'm just going to figure out what the ref count is and kill all of them. But this is the wrong way to do things. What you should actually do is just decrement the ref count when you're done. All right. Mischief managed. Oh, that wasn't so bad. I think I know what is going on here. Let us first look at the current implementation of use mempool. By the way, if you're on the stream right now, I probably can keep streaming, but I'm not going to stream this one anymore. So if you've got suggestions for what I should do next while I keep streaming, I'm all ears. Or we can also just wrap up the stream. That also would be fine as well. Okay. So this seems pretty reasonable. We seem to begin allocating to pool, and then we end allocating. However, there is a ref count leak. Let's look at begin allocate to pool. As you can see here, when the pool is pre-existing, we increment its use count. However, when we end allocating, there is no ref count decrement. So in fact, you leaked a ref count here. You empirically discovered this fact while testing your PR and stack. And I suppose this PR is your attempt to post facto fix the reference count leak. But decrementing the amount of times as the use count is a big code smell, and it is almost never what you actually want. What you actually want to do is fix the leak. By the way, the existing Cuda graph API usage of the pools does not have this problem because they do decref it. But I agree that this is very confusing and would also look positively on some sort of refactor to make the ref count state more clear. Victory! I am happy. Let's also add Z to Vito here. Okay, we're all done. Any more comments from the stream? Do we even have anyone tuned in? Let's see. Oh, we got some folks. Any requests? I'm gonna stop the recording at least.